how many of you plan on using virtual desktop to do it for free? Okay. And of those of you that are planning to use virtual desktop, how many of you have been successful at logging onto it? Nobody? Yeah. So we got at least one or two people. So we know it works. Now, I understand that there is a little bit of a problem with the the CUNY First logon for new students. So that may be like what's causing you to not be able to log on to virtual desktop. If that's the case, I'm told it was going to be resolved today or tomorrow. So try between now and Friday, try to see if you can't get onto virtual desktop and actually get SPSS to run. If you can't, let me know. So as you get towards the end of the week, let me know. Send me some emails, or actually, I'll make sure that there's a forum in the discussions board. Okay, one of the ways we're going to be communicating is through the discussions board, which is one of the tabs on Blackboard. I'll put a forum on there. We can exchange war stories on how we're getting SPSS to work. Okay, so if you're planning on doing that, you can give it a try in a few days, see if that works out. Personally, for the $40, I think it's worth downloading the cheapest version of it and installing on your computer, because it gives you a little. You lose a little bit of functionality because it is a student version. There's actually two student versions. There's a grad pack version and a base version. The base version is missing some functionality that you might be interested in towards the end of the semester in other courses, specifically logistic regression. Uses linear regression we can work with, but it doesn't have logistic regression. The more expensive one, which is about $50 or $55 for a 6-month license, has that as well. So when we get to that point, if that means something to you, you probably would be interested in doing it. If it doesn't mean anything to you and you just need SPSS to get through this course for this semester, the $40 version is fine. Okay, now, the reason I would go and spend the $40 is because once you have it installed on your computer, you don't have to have an internet connection to use it. So if you're somewhere where the internet's slow, or you don't have a connection, you don't have a password to log on somewhere, you'll still be able to work with SPSS and work on problems, practice using it, and so on and so forth, because it's on your computer. The virtual desktop, the only way you'll be able to use that is when you have a good internet connection. You can get online and you can log on to CUNY First. Okay, that's the deal there. That's how that works. In addition to that, it's a little bit awkward, because you're going to want to save your data files on your computer, even though the program is running on the server. So you got to be a little bit careful with that. In addition to that, you also want to save your work a little bit more often, because in addition to any potential bugs there might be in SPSS that might cause it to crash or something like that, you also have to deal with losing your internet connection while you're working, and then losing the work that if you haven't updated your data file, saved your data file, on your own computer, having that. So I think it's worth spending the $40, but it's not my $40. So that's up to you. All right. So you can make your own decisions on that. But homework number 1 involves, in addition to some multiple guess kind of problems, it also involves a kind of a repeat of what we did with Excel. I'm going to just run through that real quick. Okay, so I'm going to open up SPSS. A couple of ways I can do this. One way that I can do it is I can double click on an SPSS data file. Okay, mine's a little funky and buggy, so I like to start up from the actual program itself. When the program starts up, it's going to open up a window that'll give you an opportunity to open up a recently used file, to start a new data file, do a whole bunch of other exercises. It'll even show you some data files that you might have opened recently. It'll bounce around for a while, and then eventually, I hope, open. Okay, come on. Here we go. Okay. Okay, here we go. Open twice, as a matter of fact. Okay, so there we go. It's got some introductory stuff, so on a new data set, so on and so forth. This kind of like almost like a template window that opens up in Word or some other programs. If you don't want to see this again, you can just click that and say OK, and it won't come up the next time you start up SPSS, you'll just start up with a data window like that with what's behind it. You may prefer to do it that way. It's going to be a little bit less clunky to work through this window. I don't really use it for much. So typically, if you get rid of that, SPSS opens up in this fashion. Looks like an Excel file, right? Columns and rows and so on and so forth. It's nothing like an Excel file. This sheet is used only for displaying data. The rows represent individual subjects. The columns represent variables. We're going to open up a couple of data sets, and that'll be clearer to you. There's two actual windows in this file. The main window is this data file. The secondary window is something you can get to either by going down, way down to the bottom there and clicking on data view. Okay, and it gets you to what's called the variable view. You can move back and forth between the variable view and the data view if you want to. Okay, we're going to take a quick look at some data to see what the differences between those two are. So one of the ways that you can get data into SPSS is to simply type the data in. I can go into this box. Let's say I'm typing in a list of blood pressures for 10 patients. Okay, 110 to 200, let's say, 90, 135, 110, and so on and so forth. So the data now is represented in that first column. That first column represents blood pressure. So now let's say I also want to identify the gender for each one of those patients in S2SPSS in that data file. Well, in the next column, I can say, let's make the next column gender. But you know, if I type in male here, and then over here in the next box, I type in male with a capital M, as far as the computer is concerned, those are two different things. So it's kind of funky to type in text identifiers or text data into a database program or into something that's going to do calculations. So in order to avoid that issue, I'm going to use numbers instead to represent male and female. I'm going to use 1 to represent male, and I'm going to use 2 to represent female. Okay? Problem with that is now a couple issues here. One is that since I did not identify what these variables are, SPSS went ahead and gave it its own variable names. On your computers, might be. Are you guys? Any of you guys following me with this on the computers? Yeah. Oh, jeez. Okay. Okay. So the problem with this is that SPSS is a little primitive in a few ways. You know, the interface is a little primitive because it's kind of been built up from an older database program that IBM bought up. You can actually, I can't really zoom in too easily on this.
Oh, sure.
Yeah, I was going to suggest that. Yeah, I was going to do it for you. So it's kind of, I was hoping it could be on your computers, but you can, if you can look up there, you see in the first column at the top, it says VAR 00001 and VAR 002 for the next column. That's because since I didn't identify it, SPS gave it its own variable names, but they don't make any sense to us. And also the 1 and 2 is not going to make sense later on when we show this data to someone else. So we want to code this data. We want to identify this data or at least tell SPSS what the nature of the data is so that it's going to make more sense. So I'm going to click on variable view here. Okay. When I go to variable view, it now shows me 2 rows instead of 2 columns. Those 2 rows represent the nature of the data that's in the first 2 columns. So one of the first things I can do is I can change VAR 000. I can change that into blood pressure. Or how about if I just use BP to abbreviate it? Now, column number 2 is gender, right? So I can call it gender. Okay, and notice that it kind of identified these things as the first variable as numeric, the second variable as a string variable. It identified it as a string variable because I typed in male and female when I first started. Okay, but that's okay. Number or whatever number of string doesn't matter because it's only going to be a 1 or a 2. If I go all now width and decimal points, I can tell it how many decimal points are likely to be in the number that I'm going to use. And in fact, if you look at this, you'll see it's eight characters wide with 2 decimal points. I'll leave it that way. It really doesn't matter to me. And with the gender, it shows four characters wide with 0 decimals. It's always going to be 1 and 2. I'm fine with that. I'm not going to change that. If I keep going across to the other end, you can adjust the alignment so the data lines up in the center of the column or to the left or to the right if you want. You can tell it what kind of measure it is. Now, this part's important. This is where we identify the data type, the SPSS. And in the first session we spent a lot of time identifying data types. So for instance, blood pressure, that's a numeric variable, right? So SPSS gives us a chance to tell it what kind of variable it is by identifying it as scalar, which is basically numeric, as ordinal, which is a category, but a category that has various values, one greater than another. You could identify what's lesser and what's greater, such as fair, good, poor, and so on. And nominal, which basically is a name or a number, a 1 or 2 digit number. Okay, so so blood pressure is going to be a scalar variable. It's going to be a numerical variable. Gender is going to be a nominal variable. It's going to be male or female. In our case, we identified it as a 1 and a 2. So now this is perfectly okay for our use, BP. We know that means blood pressure. But when we create a graph or a table from SPSS, we're going to want to create something that someone else is going to be able to read and understand. So we don't want it to be that nebulous. So we can go in here to label, and we can tell it to call it blood pressure. Okay, and I could also put in there diastolic blood pressure, systolic blood pressure if I wanted to, but I could identify it a little bit more precisely. The other thing that excuse me? I can't. Yeah, I'm wondering if I can change my screen resolution real quick on the fly without crashing. Let's roll the dice. Let's see, displays. Let's see. Display, default display, scaled. Cross your fingers. Did that work? No, it didn't. SPSS is that way, is it? Yeah, I can't. I can't. It won't literally, what happened? It just resized the screen in here. Yeah, it blew up on my computer. It didn't increase the resolution on this. I'd have to change the resolution on here, and I'm not. Yeah, I don't want to chance having this whole thing blow up on us. Okay, so when you play this back, remember we're recording this. When you play this back, you'll be able to get a better view of it than you get right now. Okay, so I changed that to blood pressure up there. Okay, a little hard to see. The reason why I did that was under label, I put blood pressure because when you look at the variable name BP, SPSS has specific rules for variable names. Has to start with a letter, can only have letters and numbers, and it can't have any spaces or special characters. So I couldn't even separate blood and pressure if I wanted to for my displays later on. So that label allows me to tell SPSS that even though the variable name is BP, wherever you're going to use BP, now use blood pressure. Now for gender, I can do the same thing. Maybe I'll put in the sex of patient. Okay, so that'll be substituted for gender in any chart or graph that I produce. Now there's another column here called values. And again, I know you're dealing with looking at a pretty small window there. Okay, so let me see if I can't blow that window up from here. Oh, maybe. Did that work?
Yeah.
Oh, okay, good, excellent. Okay, you did get away with something there. Let me move this over a little. That's interesting. There we go. Okay. Ah, that's better, right? A little better anyway. Okay, So under values there, I'm not going to, the values for the blood pressure, which is a numerical variable, we're not going to change those. Those are going to be the same. It's just a number. The values for gender, well, now this gives me the opportunity to identify for SPSS what the 1 and 2 mean. So when I click into there, it comes up with a little box that appears to the right. And when I click on there, it comes up with a window, lets me identify those value labels. What did I say 1 was? Male. Okay, so 1 is male and 2 is female. And I'm going to click OK. Okay, so now what have we got? If I go back to the data window, data view, I see male and female substituted for the 1 and 2. Okay, there's actually a way for me to turn that on. If I go up to view, I can toggle value labels on and off so I can see what's actually there and what it represents as well. Okay, so I'll leave it turned on. Okay, so now that I've done that, I can actually go ahead and do some actual work with SPSS. The process that I've just used is called coding. Okay, I've coded the data for SPSS so it now understands the type of variable and how I want to use that variable. So now with a categorical variable, what am I going to likely want to do? For instance, gender. If I have a data set that has something like, let's say 100 patients listed in it, what might I be interested in terms of gender? Just gender all by itself as a variable. How about maybe just how many males and how many females there are? Just a count, right? Okay, let's do a quick count. Analyze. And this is basically a descriptive statistic, but it's a special kind of descriptive statistic that we're applying to nominal variables. For instance, gender, a nominal variable, I wouldn't calculate an average or a standard deviation. It would be meaningless, basically, right? So, but I am interested in the frequency. How many males, how many females are there? So now, in the frequency, I'm not interested in blood pressure because the frequency, there weren't any repeating numbers in blood pressure. The frequency would be 1 for every one of those different patients, right? Their individual blood pressure. But the gender, yeah, I am interested in the frequency for gender. So let's take a look at that. I'm going to move that in there, and I'm going to ask it to go ahead and do a frequency count for gender. So what does SPSS do? When I clicked OK, I moved that variable into the box that allowed me to do the operation. And when I clicked OK, it gave me a box that says, hey, listen, we're looking at sex of the patient. Notice it substituted sex for the patient for gender. Okay, and it said that there are 5 valid values for patients. And it said, let's see, 2 of them were male, 3 of them were female. It gave me the percentage of each group, cumulatively and individually. Okay, so we did our first statistical operation with SPSS. So now let's say I want to display that graphically. If I'm looking at nominal variables like gender, do I display a bar chart or a histogram? Bar chart, right? Histogram wouldn't mean much here, right? Descriptive statistics, frequencies, okay? I move in the variable into the variables I want to work with. SPSS gives me 2 side-by-sides lists, the variables I have in the database and the variables I want to work with. So I choose sex of patient or gender, move that into the variable I want to work with. Okay, now I can tell SPSS, SPSS is going to display frequency tables. That's checked off down here. If I wanted to make a chart, I can also ask it to create a bar chart for me. Okay, so, and those bar charts are going to be based on the frequencies, the number of people in the group, male or female. So I'm going to click continue, and SPSS is going to say, okay, now you can hit OK. That appears, and it'll create a table for me that shows me a breakdown of males and females and creates a bar chart for me as well. That's the easy way to do this. Yes?
For you're entering the variables or the data for the variables, why did you enter male or female as opposed to 1 or 2?
Well, actually, I entered 1 or 2, but then in the variable view, I identified that 1 or 2 is representing male or female. If I actually type, first of all, number 1, it's tedious for each patient for me to type in male or female when I could just enter 1 or 2. The second thing is it's less accurate. if I misspell male or female, if I use an upper or lowercase letter, as far as the computer is concerned, it's not the same category. It's not the same value. So it's better to use numbers and then identify for SPSS what those numbers represent. Okay, so this created this chart for me, right? That frequency chart. So there's a lot of other ways that we could have created a pie chart and so on and so forth. If you just want to create a chart, there is a graphing function where you can go. Most of the statistical functions will give you access to the graphing functions pretty easily. What I was trying to do is go into legacy dialogues, click bar chart, right, and tell it I want a simple bar chart like the one I just created with male and female side by side. Okay, but first I had to tell it you want to summarize this bar chart by groups of cases. In other words, males and females. I moved down to individual cases. We don't want that. Okay, and then I had to tell it what the variable is that I want to work with. Okay, and the variable I want to work with was listed, is already in here, was moved over. Won't let me move it back. Was moved over from SPSS. Oh, here we go. Was originally listed there, and it in order to tell it that I wanted to give me a bar chart for this particular variable, I have to move it into the category axis. That's the x-axis is the category axis. Okay, so the x-axis is going to be male and female. And then I click, you can't see it here, but I'm going to click OK, or you can see it. No, you can't see it. I'm going to click OK down here, and it produces the same bar chart. That graphing function did the same thing as the analysis function. As you get familiar with SPSS, you will have your own way of doing these things because there's going to be a million ways for you to use different functions in SPSS to accomplish the same thing. Excel also is kind of that way. There's a lot of ways to skin a cat in Excel. You don't always have to do it exactly the same way. Okay, so let's take a look at numerical variables. Okay, what kind of analysis do I do with numerical variables, like blood pressure, for instance? What would I do? I mean, how would I characterize a sample of 100 people's blood pressures?
Histogram.
A histogram would be good. Graphically, histogram is the way to go, right? Okay, well, how about numerically? You know, I have a list of 100 blood pressures, but that's not a good way for me to communicate that information. Yes. Yeah, descriptors, yeah, mean, median, and so on and so forth, right? All the stuff we're talking about. So let's see how we would do this here. Okay, remember, all this data is already listed in our data file, right? I'm using a tiny data set, okay? But it works the same way with any size data set. So I'm going to go into Analyze and Descriptive Statistics, except with frequencies, we were interested in just counts, okay? With the nominal data, we just interested in counts. With numerical data, we're interested in more involved descriptive statistics, like a mean, median, and so on and so forth. Again, SPSS brings up I go to Analyze Descriptive Statistics. It brings up a box that says, okay, here's your variables. Here's your available variables. Which ones do you want to work with? Well, I'm not going to move gender in there. I'm not going to move sex of the patient in there because the mean and median, that would be meaningless. I'm going to move blood pressure in there. Okay, I have some options. I'm not going to worry about that right now. Basically, options are mean, standard deviation, and some other stuff. I could ask it to find the range, the variance, and so on. Click Continue, and I'll click OK. SPSS now takes that data and finds all that information for you. I'm going to run it again so I can raise it up on the screen and you can see it. Descriptive statistics, descriptives. And I'm going to say OK. Again, it's going to do the same operation. So you can see it there. Here we go with there's our number of our count of patients was 5. The range was 110. That's from the minimum to maximum. The minimum was 90. Lowest blood pressure, highest blood pressure was 200. The mean was 129. The standard deviation and the variance are given right there. So that's an alternative to calculating it in Excel, right? Pretty good alternative because it comes through pretty quickly. Now let's say I want to find some more information about this. I'm going to go Analyze again, Descriptive Statistics. I'm going to go past frequencies, nominal data, past descriptives. I'm going to go to Explore. Okay, that's going to give me descriptive statistics also, except this time it gives me a bit more flexibility. Okay, I'm going to find my numerical variable is the blood pressure. I'm going to move that into my main operational window. They call it dependence list. But this is the variable I'm going to work with to find the descriptive statistics. Now, there's a box here that says factor, right? Factor means you're going to break it up into different groups, just like a factor number. 36 is 6 times 6, right? So I'm going to factor it up, break it up into different groups. Which groups do I want to break it up into? Well, how about if we break it up by the gender of the patient? So now I can not just find the descriptive statistics for all the patients together, but I can compare males and females based on what I know, which patients I know or which patients I know, and SPSS knows are males and females. What can I do besides that? Well, let me click into statistics. When I click into statistics, I get a window that basically doesn't give me much flexibility. It just says descriptive statistics with a tick mark on it, right? That's because it's basically going to give me everything. Either you want descriptive statistics or you don't want it. So I want it. So I'm going to leave that checked off. Now, if I go into plots, it gives me the opportunity to get all sorts of different graphical displays. For instance, stem and leaf. Okay, that's kind of an ancient form of creating a histogram, but I want a real histogram created for both of these variables, for both of these groups. So I'm going to click histogram. I'm going to click OK, continue, and OK. And SPSS is going to analyze the data and look at all the descriptive statistics that came up for each of these two groups. The mean for males was 155, the means for females was 111, so on and so forth. Okay, and here's a histogram for males. Here's a histogram for females. If I can get it to scroll up. Okay, there aren't really much in the way of histograms because there's almost no data in here at all. But you can see how we create it for you. Okay, and here are box plots for male and female plotted side by side. We're going to give this exercise a try again. If you can get onto Blackboard and download that file, that North Carolina birth file, I'll give you a chance to open it up, and we're going to repeat this process, except we're going to do it with that larger data set. That's 800 births in the state of North Carolina sometime in the late 90s or something like that. There's a Word document on Blackboard. Looks something like this, which is kind of step by step the operation that we're going to go through. Okay, so let me point something else out here. Did you guys notice that when I did a statistical calculation, I'm going to go to data view. I'm going to repeat the analysis I just did, analyze, descriptive statistics, explore, and it's already still set up, so I'm going to click OK. Another window popped up on SPSS, an output window. SPSS has two different windows, one for your data input or your data storage, which has your data view and your variable view. That's one window. And that can be saved. If I want to save it right now, I can say save as, okay, and give it a name, and it'll save it. I'm going to save it into my documents. Give it a name, click save, and we'll save that. It was named untitled. We'll save it as untitled.sav. SAV is the postscript for a data file. Okay. However, if I close this whole thing now, I will lose the output file. The output file is a separate window and a separate file. If I want to save the output file, I do the same thing. File, save as, and this time it's output one, and the output is going to be a .spv or .spo file, depending on the version that you're using. And I'm going to click save, and it'll save it. There's another one. I'll replace it. It doesn't really matter to me, right? So now those the data and the output files are both saved. Right? If you don't save them both, you won't have both of them in the future. Now, one of the other things that's interesting that's going on here is that SPSS, how are we doing on time? I don't have a watch on me. 6:52. 6:52, so we got 7:50. Okay, good. We got plenty of time. Good. Okay. So one of the other things that I notice here is that it has two windows. And this output window is starting to create a sidebar here. And this sidebar contains all of the operations that I've been working on so far. So if you spend a long time working on SPSS, right, and you say, well, gee, let me go back to when I did this explore. If you click on that, it'll take you right back to the location that you were at before. So this is kind of an area where you could tab through your different operations. Anybody notice anything else unusual that SPSS was putting up there besides these boxes? You see it? That right, syntax. Okay. What is syntax? Anybody want to hazard a guess? Yes, it's basically a language that SPSS understands that's basically English-like. So for instance, the operation that we just did, create a simple bar graph for the value gender, that would be the instructions that you could type in to ask SPSS to do that operation. So when I did the frequency variables for gender, it basically did the operation frequencies, variables equal gender, / order equal analysis. If I take that text, I'll see if I can copy it. If I copy that, if I go up to File, in SPSS, if I go up to File and say New, one of the things we already took a look at what happens when you say New Data. It brings up that blank window. Okay, how about if I go into Syntax? It brings up a syntax window. And if I paste that data into the syntax window, it will allow me to go ahead and if I say run that run that, okay, it'll do the operation that I just did with the drop menus. Well, what's the strength of that? That means that you can set up operations that you create syntaxes for, where you have a lot of operation, where maybe an analysis that you have to do every day on new data, so you don't have to go through the various menus and setting up the data and so on and so forth. For our situation, perhaps the syntax is not something that you're going to need to learn how to do. But one of the things that it'll help you with is that if I create an output window and you say, well, how did he get that graph? You can actually take a look at this and deduce that I got this graph by going to the graphing command on the menu and asking it to create a simple bar graph with a value gender. Okay, you can use this kind of track back what I've done for all these different operations. Okay, or what you've done if necessary for all these different operations. Okay, so we have a data window, we have an output window, and we have a syntax window. We also got one other window, which you're probably not going to get too involved with, and that's called a script window. If you take a look at that, that actually, many versions of SPSS have the ability to have a programming language embedded within the program or referenced outside of the program. In this case, the version I have installed has access to a language called Python. So if you know how to program in Python, you can program SPSS operations in the programming language Python. Anybody know Python here? Yeah, okay. So you could actually, if you wanted to play around with it, you could, find the links and stuff, so on and so forth, the commands you need to access data and run analysis programs in Python. If you're going to get into this, I would say don't bother. If you really want to get into using a programming language to do statistical analyses, I'd stick with R. I think it's more functional than otherwise, unless you're really kind of a serious programmer. Okay, but nowadays, for most statisticians, real statisticians, the default is becoming R. Okay, so I'm going to open up a new data file. I'm going to go to File, Open, Data. Okay, and I'm going to go to my desktop where I know I have this stuff stored. And I'm going to open up that data file, which is called NC Birth. I have it in here on September 12th. And there it is, right there. Okay, there's let's see. I actually have two versions of it. I'm not sure why. Okay, but here we go. .sav is an SPSS file. I'm going to open it. Oops. There's an issue with the different coding for text, ASCII coding for text in the different versions of SPSS. I've heard different opinions, even from IBM, on which you should use Unicode or local encoding. Most of the new programs use Unicode. right? So it might be nice to set it up that way. Don't worry about it. There's a way to change back and forth. And for the most part, it's going to come up with a warning when it doesn't know what kind of coding it uses. You can just say, don't worry about it, and it'll open it for you anyway for the most part. Okay, so you can kind of ignore that for the time being. Okay, so now here's SPSS. What view is this that we're in right now? That's a variable view, right? Right, so I'm going to switch to the data view. There's the data, right? So what do we have in the data? We have plurality. Anybody know what plurality stands for? Think births, right? Number of children on that birth, right? Well, so it's mostly going to be ones. You might see an occasional two. Okay, sex. Sex is sex. That's not the sex of the mother. Obviously that's the sex of the baby, right? The gender of the baby. Age, mother's age. Kind of inconvenient variable names, right? We don't want those on the tables we're going to produce. So I'm going to go to the variable view, and if we look at this, it's already been coded. This data, right? Somebody has already gone through this data and done the coding here. So let's say plurality is a number of children born during that pregnancy, right? That is, it's set it up as a nominal value. I'm not going to worry about that. Okay, sex of the child. It's set it up as a nominal value, male or female. And someone went into the values and said, okay, 1 is equal to male, 2 is equal to female. The actual data is 1s and 2s. Okay, and so on for all these different variables. Marital status, the race of the mother, the whether the mother is of Hispanic origin, that's a yes or a no, right? So that's a nominal variable. Weight gain during pregnancy, that's a nominal variable. That's a numerical variable. If you look over here, you can see the types of variables that we're dealing with. And when you start to seriously work with this, you're going to want to check that just to make sure SPSS, if you guessed at it, doesn't get it wrong, because it may keep you from doing certain operations. Okay, so let's take a look at this. Let's go back to our data view. Okay, so let's pick out a nominal variable like gender, right? Okay, what do we want to do with gender possibly? We want to go into analyze, descriptive statistics. Where am I going with this? We're gender. Frequencies, right? I don't want to go to descriptive statistics, right? Everybody understand why I don't want to go into descriptive statistics for gender, because the average of number of males and females doesn't really mean anything. Okay, so I'll go into frequencies. Okay, I'm going to choose the sex of the child or gender, move that into my variables box. I can actually do more than one. There's a let's see, smoke during pregnancy. I'm going to move that in there too. I can work with more than one variable at once. Okay, and I'm going to ask it to, statistics. I'm not going to ask it to do any of these statistics because it's not the numerical data. Okay, I'm going to go into charts, and I will ask it to make bar charts for each one of these. Okay, and base it on the frequencies, the number of people, the number of cases that are represented. And I'll click continue, and I'll click OK. Okay, let's see what we get. Now remember, this is just adding on to the same output sheet that I've had open here all along. Okay, so what do we have? Let's see, there were more male children in this 800 sample of 800 than there were female children. Okay, it looks like about 410 to about 390 or so. Okay, what about smoke during pregnancy? Well, relatively few women smoke during pregnancy. It looks like about 100 and 700 that did. There's 800 women in this whole survey. Actually, that's unusual, right? That is almost a giveaway to the fact that this data is pretty old, right? Most mothers would not admit to smoking during pregnancy, nowadays. Probably the proportion would be a lot lower. If I wanted to, I could have said descriptive statistics frequencies, and I could have said, display the chart by percentages rather than by the actual number. See how that looks. And again, it's adding to the bottom. And here we go. So 85% of the mothers did not smoke, and 15% of the mothers did smoke, okay, instead of frequencies. Okay, let's go to Analyze, Descriptive Statistics, and let's go to take a look at a numerical variable this time. So I'm going to start with descriptives. Now, which of these, somebody pick one out. Weight? Okay, how much weight was gained during pregnancy? Okay, I'm going to move that into this box. Okay, my options are mean, median, variance, variable, range. I'll pick a bunch of stuff out. I'm going to say OK. Okay, so here's our data down at the bottom. I'll repeat it so that we can see it a little bit easier. Okay, that's what we get when we go to descriptives. Okay, there's our information there. Let me just check online, make sure we're okay. Okay, no questions online so far. Okay, so here's our variables. Here's our various variables and so on. Our results for that variable. Okay, 777 women. The range of weight gain was from 0 weight gain to 95. I'm thinking that 0 is probably a typo. Okay, in the data is probably an issue with the data. You might actually see that in a moment when we do some other analysis. The average weight gain was 30.38 pounds. So now we have a standard deviation of variance. Well, now let's say I wanted to know, well, let me analyze what was the amount of weight gained by mothers who smoked versus mothers who didn't smoke. So what do I have to do there? I have to separate the data for the mothers who smoked to the mothers who didn't smoke. So, yes. So I'm going to go to descriptive statistics. I'm going to go to descriptives. Yes, no? Explore, right. If I go into descriptive statistics, it doesn't give me a chance to break it up into different groups, right? But if I go into analyze, descriptive statistics, and I go into explore, well, now I can tell that I want to know the weight gained by the mother, but I want to factor that into two groups. I want to factor it into the smoking history of the mother during pregnancy. Okay, ones and twos, right? Okay, so let's see what I want. I want my descriptive statistics. It's going to do a lot for us, right? So I don't have to worry about that. Plots. This time, I want to see a histogram this time. It may make sense because now I'm working with decent sized samples. It'll give me an idea of whether this distribution is really normal. So I'm going to click continue. I'm going to click OK. And again, adds to the end of the data. And let's see, 664 women did not smoke during pregnancy, 113 did smoke. I don't know what happened to the other 8 women. Okay, and the average weight gains for mothers who did not smoke was 30.65. For mothers who did smoke was 30.19. Not much of a difference, right? Doesn't look like very much of a difference. Well, here's our histogram for weight gain during pregnancy for mothers who did not smoke. What kind of distribution is that? It's normal, right? So it's roughly normal. Is it skewed? Oh, I don't know about that. Looks to me like we have values out here, right, that are pulling this over. Let me give you an example. Let's say that you guys go out and you get jobs in public health, and I ask all of your classmates and you to let me know what your salary is, and you all come back and I calculate the average salary. Okay. Well, the mean and the median are like, if it's normally distributed, the mean and the median are going to be the same, right? So what's going to happen if one of you signs a contract with the NBA? Well, now all of a sudden, the median is going to stay here because, the middle value is not going to change much because this guy's making $5 billion, right? But the average now is going to be way up here. So when you have an outlier, when you have something that skews the distribution, what it does is it pulls the mean away from the median. So instead of the mean and the median being the same, the mean is pulled away either to the left or to the right. In this case, these values are going to pull the mean away from the median. So this distribution is skewed. Which way is it skewed? To the right. And another way of saying to the right is the numbers go up, so it's skewed positively. Right? So if we had a lot of values down here, right, then we would have said it was skewed negatively, right? But these guys over here are pulling the average up away from the median, right? The median is pretty stable, even though we have a few people that gained a lot of weight. But the mean is actually affected a lot more. Okay, so we can see that that's kind of right. So let's take a look at this other one. We kind of see the same kind of distribution there as well. A little bit clunkier because it's a smaller sample because fewer women smoke. But it doesn't look like there's that much difference between these two in terms of where the median is. And there it is. There's our box plot. See, the median is very close. The spread is very similar as well. right? And this is 50% of the values for mothers who did not smoke. This is the middle 50%. Mothers did smoke. Looks really similar, doesn't it? Let's try let's try a different one. How about the weight of the infant at birth? See if it's different there. So this is like the power of SPSS. You can go back and do a lot of this stuff and examine data with a lot of detail with very little effort. Okay, of course you got to know how to use it because it's equally easy to make big mistakes as do good work with it. So this I'm going to get weight gain during pregnancy out. I'm going to look for the weight of the child. Now one of these is ounces, one of these is grams. Let's use grams. Doesn't really matter, right? It's really the same thing. And these statistics and plots are already set up. I haven't changed it. Let's see what happens now. Okay, how much was the average weight of at birth of the child for mothers who did not smoke? Was 3,300 grams. How about for mothers who did smoke? It's 3,100 grams. Oh, we're starting to see a real difference there, right? The weight gain didn't change, but now the birth weight of the infant was different. What about the weight gain of the child? How is this skewed? Negatively. Why is it skewed negatively? What happened with these children down here? Right? What are they? They're premature births. Right, exactly. So if the average weight of the child, let's say, I'm not an expert in this by any means, but an average weight of a child is what, 7.5 pounds or something like that?
3,000.
What's that? 3,000 grams? A really big child is what? 4,000?
4,500.
Yeah, that's really big. But you get a premature birth, it could be 1,000 grams, right? So it's not unexpected that this distribution would be negatively skewed because more likely you're going to get extreme values on the low end than extreme values on the high end, right? So it kind of makes sense that we would see that kind of distribution. Let's take a look at the box plots here. And this is for mothers. Let's take a look at the box plots and see what we see. Well, the box plots are pretty informative here. Look at all these outliers here, right? This is mothers who did not smoke. We have some outliers here as well. Okay, so what about the medians? We see the difference in the median. Okay, now, as we go on through the semester, we're going to figure out how to determine whether this difference in the median is statistically significant. In other words, if this is just chance because that's just the way it happened with these 800 women, or if that's really meaningful in terms of, the probability of this happening just by chance, or because smoking really impacted the birth weight of the child. Okay, when we get into hypothesis testing, we're going to be examining that. Okay, any questions so far about this? You guys comfortable with this? Right? You're going to be able to go home now and except the fact that you don't have SPSS, you're going to be able to do the kind of a similar exercise as this, okay, with SPSS. So let me just check with these guys online, see how they're doing. Okay. Hi guys, Joshua, are you guys keeping up with this? Okay, doing good. Thank you. Okay, good. All right. Okay, I can see the clock now, at least anyway. All right. So we have a lot of other data that's over here that we can work with. Now, let's say that we have more than 2 cases. Okay, so let's take a look at that. Let's take a look at create a graph, and let's say we want to create. I'm going to go back to our bar chart for variables. I'm going to say clustered this time. See if it'll work with this. And I'm going to define it, and I'm going to say that we want to work with let's see. I don't want to do that. So I'm going to analyze descriptive statistics, explore. This time, I'm going to take a look at a situation where we have just more than 2 values for a nominal variable. For instance, the race of the mother. And I'm going to move that into our factor list. And this time, I'm going to calculate the means, medians, standard deviations for each of the different ethnic groups that we might be dealing with. And I'll be creating 4 side-by-side box plots. Let's get down to them. Okay, and here we are. We created a different box plot for each one of these different ethnic groups.
Did you say you got a frequency table as well?
Yeah, let's see. No, I didn't get. I asked for descriptive statistics. I created a frequency, what it calls a case processing summary. Okay, where it tells me how many of the subjects were in each one of the different groups that I identified, nominal groups that I identified. Right, 604 white women, 169 black women, American Indian. Obviously, Chinese and Filipino. We're not going to get much data from because there are only one or two individuals in those groups.
Sorry, I didn't realize that table was going to come out.
Okay, so now this is great. You can save this as an output table, right? The output table is saved. You can open it up later on, look at the data you've processed, and so on and so forth. Okay, the only problem is that most of the time you're not going to be giving this data to someone who is going to use it with SPSS. You're going to be wanting to communicate this data to colleagues, to other students. You want to use it in a report or something like that. So we want to copy this data out, and we want to use it in say a report or a paper or something like that. So what we can do is we can go to, I'm going to open up Word, Microsoft Word. Okay, and my version of SPSS is a little bit buggy, and I sometimes have problems with this. This is, as I was saying, this is the gallery that opens up. Okay. I still have the screen blown up. That's why I'm experiencing a little bit difficulty with this. Okay, I'm going to narrow this a little bit so I can work with both at the same time, almost. Okay, so I'm going to take one of the tables that I've generated here. I'm going to take a simple one. Okay, I'm going to take this one. Okay, this is the frequency for the gender of the child. I'm going to click into it. If I click away, you'll see it doesn't have a highlighting bar around it. If I click into it, now the highlighting bar appears. I'm going to go up here and say copy, or Control C or Command C, whatever computer you're working with. I'm going to go in here and I'm going to say paste. Okay, you can take that table from SPSS and paste it into a Word document. You can move text around inside of it. You can resize it. You can even edit this text box. Say that's a number that's particularly important. I'll make that number red so that, and bold, let's say, so it's highlighted within that table. You can work with it in either program. You can also work with it in SPSS. Right? If I go into SPSS, if I go in here, I can take a table or chart. It'll pop open in in an editing window, and I can actually go in here and I can modify it. I'm going to change the font on here to whatever that is, or maybe just change the size. Right? I can modify it there as well, and then click away, and it's saved, and you can copy it out into another document if you want. Okay. The other thing you can do is you can do the same thing with charts. I'm going to click onto that chart. I'm going to say copy. Cross your fingers for me. Doesn't always work for me. Let me go back to Word. I'm going to say edit. Oh, not there. I don't know what it is. Sometimes it works. Sometimes it doesn't work. It may have to do with what operations I've been doing. Copy. Looks like it copied. No, okay, let's give it a try. Hit paste. It's invisible. Try it this way. Copy. Okay. Nope, doesn't like that. Try a different one. In your version, you should have no problem with this. I'm going to put a break in. A change of view. Oh, there it is. Just doesn't like that view. It actually did paste in. You couldn't see it in that view. You can actually paste an image in from SPSS. You can use this in a report now. And that's the value of, did we change any of this? That's the value of, for instance, instead of, I think it was M weight or something like that for mother's weight gain, instead of M weight, it substitutes the label that you identified in there instead. So someone reading this, that would have some value. You can actually resize this now and so on and so forth. One of the other things you can do, and again, we have a few very large tables like this table. If I click in there, I can copy and paste that as well. Copy. Go into Word again. Okay, let me get a fresh page. Let me get a new page. Okay, now if I paste this in here, right, it's a little bit of a mess, right? Spread across a couple of pages and so on and so forth. If I want to resize it, it's a table, basically a table. The nice thing is I can go in here and edit this, highlight it, edit it, change colors, so on and so forth, change the width. Notice all the tagging on the top there for the width of various columns. I can manipulate the width of the columns, but to be honest with you, sometimes that's more trouble than it's worth. And some tables will extend past the edge of the page, which is really a pain in the butt, right? So what you can do in some cases, and again, this is hit and miss on mine, you go up here to edit and say paste special instead of paste. And when you say paste special instead of paste, it comes up with a series of options. You want it, right now we're pasting it as formatted text. You could instead paste it as unformatted text, not much advantage to that. Style text, not much advantage to that. But most of you will have an option here that will say bitmap or JPEG, which means that you can paste it in as a picture. So the table is now a picture instead of being a text object, which means that you can manipulate it the same way that you would manipulate one of these drawings, one of these pictures. In other words, you can resize it and move it around the document more easily. What do you lose when you do that? You lose the ability to actually go in and modify it in Word, because now it's a picture instead of a text document. Okay, so you get an opportunity to do that. Are you guys doing this as well? How many of you guys are actually doing this with me? Couple? Okay, good. All right. So that's one of the big advantages of this. One of the other things you can do with SPSS is that you want those pictures, you want those charts, but they're not so portable in that SPO file or SPV file, that output file. What you can also do is go up here to File. You can say Save As, and you can choose to save it instead of an SPV file. Nope, it's not there. Let me try again. Save as export. Here it is, export. You can say export, and you can tell it to export it as a Word or RTF. RTF stands for rich text file, okay, which is basically a file that includes graphics. You can save it as a rich text file, right? And you can save all the objects or only selected objects within that device. And I'm going to save this up on my desktop just so you can see what it's going to look like. Save. Oh, I didn't give it a file name. RTF file. Exported to RTF file. Okay. And for the RTF file, and I lost my, okay, yeah, so my window's so big. Okay, saving. Okay, let me get all this stuff out of the way now. Go to my desktop. See if that's really there. Oops, excuse me. Okay. There's my desktop. Okay, by date. There's the file. Nope, that's not it. Here's the file right there. Okay, I'm going to open that in Word. See what it looks like. There it is. There's a Word document with all of the output that was in that SPSS output window. Right. So you can save that if you need to scavenge the data later on for a report or something of that nature. Okay, every bit of it is there if you want to save that whole file. But again, the real strength here is that you get to create all this nice graphics and all this information in SPSS and then use it for whatever you need it for. How many of you guys have taken EPI this semester? Yeah, so if you have a project that you have to analyze some data or something like this, now you'll be able to use this to, analyze the data, produce some nice charts and graphs and so on and so forth, and use them in whatever you're using there. How many of you, after I spoke about this today, are going to rent SPSS instead of relying on virtual desktop? Anybody change their mind? A couple of people changed their mind. Okay, not many. A couple of people. I don't get a retainer or commission from IBM. Trust me, IBM doesn't know who I am, and I like it that way. So don't mention my name there. Okay. By the way, they're pretty cooperative. If you have problems with the installation and stuff like that, they're pretty cooperative, and I think they use online chats and a few other things. But they're very cooperative with students on helping them if they have issues with the installation. You should be wind up with a separate document which has a license on it, and there's an installer program where you put the license key in and stuff. So, but it'll give you the instructions when you download it. Okay, so let me see what else now I wanted to just quickly go over something that we did last time, so you get a look at what remember that formula we just saw? That let me see if I can't find a quick version of it. Okay, formula for standard deviation. Okay, go to images. Okay, here we go. There it is. This is one version of the formula, right? There's another version of the formula. It's really the same formula. Well, actually, this one's not so good. This is really it, divided by n minus 1. Let me see if I got one that kind of looks a little bit more like what Levi showed you with the n minus 1 outside of the. But you'll take my word for it that it's equivalent. Okay, let's take a look at this formula. Okay, this is the formula that Levi had up on the board. The only difference is that I think he had this in parentheses and n minus 1 outside and so on and so forth. But what's going on here? What's going on here is it's saying that the standard deviation for the sample, represented by x, for the population it would be a sigma, right? Curly Q, right? So the standard deviation for the sample is equal to the difference between the mean and each individual value. Oh, you know what it is? Yeah, you got summation, right? This is a summation of all of the means and individual values. That's what x is. You might sometimes see n is equal to 1 through the total through n. In other words, every value, the first value to the last value. Right? You want to add up if there's 20 x's, you want to do all the first one, second one, third one. You're going to take each one of them, subtract the mean from it, square it, add them all together. That's the sum of the differences of the squares. They abbreviate that sum of squares sometimes, capital S, capital S. Right? You're going to take that, divide it by the sample size minus 1. And why do we do that again? Because since we're using the mean, there's extra variability there. So we use n minus 1 instead of n to make up for that extra variability. Okay, so now, there's another way to look at this n minus 1. And a lot of times it's called degrees of freedom. If you think about it, it kind of makes a little bit of sense. When you have one value, how many degrees of freedom do you have for the number? 0. That's it. When you have two numbers, how many degrees of freedom you have? 2, right? Well, you have 1 degree of freedom, right? You can choose one or the other number. When you have 10 numbers, how many degrees of freedom you have? 9, right? So that's where that term degrees of freedom comes from.
Freedom to choose one
those values.
Yeah, exactly. So if you have 10 values, you're going to choose one out of the 10. So you have nine choices.
You don't have 10 choices.
Well, if you start with 2, how many choices you got? You got to choose one or the other, right? Right. So you got one. If you got 3, right? You have 2 choices, right?
Well, how?
Okay, so this is based on the idea that you start with 1, you have 0 choices.
Choices. If you start with 2, you have 2 choices. You can choose one or the other. You have 2 choices. Yeah, 0 choices. You have one. If you start with 1, you have no choices, right? It's already automatically that number. If you have 2, you now have one additional choice to the no choice, right? So you have one choice. Well, not if you think about it. You start with one number, there's no choice, right? So if you add a number, you now have one alternative. It's really kind of what degrees of freedom is really how many alternatives you have besides that one number.
Okay, you're looking at it from an original value.
Yeah, exactly. Okay, so that's kind of like where the term degrees of freedom comes from. Okay, so how do I do that? What's going on here? Well, I'm going to open up a file in Excel. Okay, just as a reminder what we did the last time, where that formula came from, or how we apply that formula. Open, recent, maybe I got it here somewhere. Okay, did I post a file? Did I post a video on age adjustment? No, right? I'm going to post it. I'll put it up there. I'm going to introduce it now, and then you can watch the actual video. Let's see. Do I have it here? No, I'll do it this way. Open. Okay, this is a simple file, like the first one we started with. On desktop, go in here, and what do I have here? Okay, and if you guys remember, what did I do here? First thing I did was calculate the mean, right? Mean is equal to the average of all of these values. Okay, our mean is 99.94. Okay, actually, I'm gonna round all these values off just so we don't get a headache doing this. Okay, I'm gonna format cells, and I think we have a video from session 1 that covers a lot of this. And if it isn't there, I'll make sure that it's up there. I'm gonna say that we're gonna work with. We're gonna give this 1 decimal point. I'm gonna stick with 1 decimal point. Okay, so there's our mean is 99.9. Okay. Now, Excel remembers the actual value. Even though it shows 99.9, it remembers the actual value. So if I do some operation on that, like multiply it by 2, it's going to multiply the actual value by 2, not 99.9. Okay, but that's what my mean is. So now I'm going to just copy my mean in here. Equals just this value. Okay, now to keep that value, I want to copy that value down. Right, so I could either just copy down equals B21 that number of times, or I could just put a $sign in front of these two things to let it know that no matter what I do, that's the cell that I want to replicate. Right, that's called absolute addressing. Okay, so when I copy this value down, so you guys, when I'm doing all this, it rings a bell, right? Okay, good. Right, so I copied all those values down. And again, the videos should be up there. If it isn't, I'll make sure it is. So, well, X bar is the mean. X bar is the sample mean. I call it X bar because it's hard for me to draw a bar.
I was just wondering, why have the column value?
Oh, because what I'm going to do next is I'm going to take the difference is equal to X minus X bar. I could have done that without doing that second column, but it's just convenient to have right next to it. Okay, so now I'm going to copy that formula all the way down. Right, so it's going to calculate the difference between the mean and each individual values. That's what we started with. X minus X bar is what's now in each one of these cells. Okay, that's the difference between the mean and each individual value. There's negative and positive numbers, so now I'm going to square it. Okay, this is the squaring of the sum of the differences in the means. Equals this times itself. Okay, and I'm going to copy that down. Okay, it's not actually 0.9. If I go in there, just so you know, I'm not lying to you. If If I go in there and increase the decimal places, you can see it actually is a different number. It just happens that it looks like it's the same. Okay, so I'm going to copy that down. I'm going to do the same operation, square each one of these things. Okay, so this is all of this column represents all of the squares of the differences between the mean and the individual values. I'm going to add them up together. What's this called now? What's this number called now? Sum of squares. Sum of the squares are the differences, to be more accurate, but most people just call it sum of squares. Okay, so now I got the sum of squares. How do I calculate the variance? I divide the sum of squares. Remember what was inside that square root? Divide the sum of squares by 18 or 17, right? By n minus 1, which was, I think, 17, right? Yeah. No, I think it's, no, 19. We started in cell 2. So there's 18 values, right? So this would be 17. Okay. Oops, I forgot equals that divided by 17. Okay, how do I could actually get that 17 from here if I wanted to. Equals count. I can ask it to do a count for me if I'm too lazy to actually figure it out myself. Okay, there's our count, 18, and this could be equal to this divided by that cell. Okay, it comes out to 49.6.
Minus 1.
Oh, I forgot that. Oh, my goodness. Okay, minus 1. Good catch. Okay, and the standard deviation was what? That S was equal to the square root of that whole thing. And there is a function square root. SQRT, parentheses, and you'll notice that SPS Excel, when you've got it right, and put the first parentheses in, it'll tell you what it's looking for next. So it's basically just looking for single number, which is going to be that one. Hit enter. And there's our standard deviation.
Tricky, sorry, I know this is going back. What's the trick you did with the dollar sign?
Okay.
The X bar?
Normally, if I have 12, 22, 34, 44. Okay, let's say I have a number here, like 50. And I want to multiply each of these by 50, right? I want to say, okay, this is going to be equal to what's in this cell times, where is it? Times what's in this cell. And that works perfectly okay. 50 times 12, 600, right? Now let's say I want to copy that formula down. The copy down works well when you have adjoining columns. If I use it now, it says, oh, when you wanted to advance, since I'm sitting next to a column here, when you do this, the next cell, you wanted to advance each cell. You want B31 times B39, which is empty. And the next one, you want B32 times B40, the next empty cell. So it doesn't work. If I had had 50 in each one of these cells, right? And I had said, okay, this is equal to 50 times this number, right? And I had copied this down, it would work perfectly okay, right? That works, okay? But since I did it this way, that's equal to this number times 50. Well, when I try and copy it down, I get an error, right? So now how do I fix that? I want to tell it, I want you to advance the first number, so I get to 22 to 34 to 44, but I want you to multiply it by the same cell. Don't advance that cell. So the way I can tell that, to do that, is by putting a dollar sign in front of it. And that tells it, well, in anytime I copy this formula somewhere else, don't change the cell location. Don't adjust the cell location. Just use exactly that cell. So when I copy this down now, it comes out right, because if I click in here, it really is B33 times this cell, right? So that's called, when you do it normally, it's called relative addressing. When you do it, if you nail it into a certain spot, it's called absolute addressing. And you can actually tell it to freeze the row by just putting the dollar in front of the B, but not freeze the column by putting a dollar in front of the B, but not freeze the row by not putting a dollar in front of 35, and vice versa, just freeze the column or row. In this case, we're freezing both by putting a dollar sign in front of the B and a dollar sign in front of the 38. Okay, so what else do we need to know? What else do we typically do in this situation? Well, we might find the minimum, and of course, there's a function for minimum. We might find the maximum. We might find the range. Now, one of the things that you guys, the range is just the difference between the minimum and the maximum. One of the things some people have issues with is percentiles, right? So now things get a little tricky. You want to know something? When you do this if you took these numbers and did the calculation in Excel and did it in SPSS, you get two different answers for the interquartile range. Okay, and I'm going to show you why that happens. Okay, so now 75th percentile is going to be equal. The way we do that is going to see it. Yeah, I know. Yep, that's senior moment. Equals, okay, the command is percentile, conveniently enough, parentheses. By the way, there's a lot of other versions of this command, percentile.exec, percentile. They have special applications, you can use them, but most of these commands you can just, for our purpose, you can just use them with the raw command. Okay, and it's looking for an array. It's looking for the list of numbers. And the list of numbers is all the way back over here. Okay, here's our list of numbers. And the numbers are represented by A2 to A18. Okay, and then it wants a comma. And then after that, it wants something called K. K is the percentile. Okay, in this case, it's 0.75. You express it as a decimal point, 0.75. So the 75th percentile comes out to be 104. Notice it came out to be a round number. Okay. What about the 25th percentile? Percentile. I do the same thing. A2 colon A18. Was it 18? A19. A19 comma 0.25 for the 25th percentile. And hit enter. Okay. Actually, I didn't come out to a whole number that time. Okay. So now, find the interquartile range. It's just enough. 50% of the population is between those two. So it's 104 minus 95.4. Now, dirty little secret. The way that Excel, I'm going to make this smaller so we can see all the numbers. The way that Excel handles this, a little bit bigger. Okay, the way Excel handles this is that there are 18 numbers in here, right? So Excel would look at the first 9 numbers and the second 9 numbers, and if it asks for the 50th percentile, it would give you the median, which is the average between 80. Oh, actually, no, hang on a second here. I really should just copy this somewhere else and then sort it. Okay, you guys, if you're not familiar with Excel, trust me, once you start to play with it, this stuff will come to you very quickly. What happened? What's not happy about? Sort by missing column, row name. I don't want the whole column. I don't want the whole row. Just one. It doesn't like being in a row with the other stuff. I'll put it over here. Sort. Okay. So here it is sorted in order, I think. What? Why is 99 at the top?
Your data has headers.
What's that?
Your data has headers.
No, I just copied over the numbers. Try it again.
You check, see the box that says 99.
Oh, it's 99. Yeah, that thinks that's a header. Yeah. Okay, there we are. That's better. Okay, so now the first 2, 3, 6, 9 numbers. Okay, in order to calculate the mean, and these are the second 9 numbers, in order to calculate the 50th percentile, Excel averages 101 and 103, and it'll tell me that the median is 102 in this particular group of numbers, right? How does it calculate the 25th percentile? Well, it says this is the lower half, right? So what is the median of the lower half? 94. Calls the 25th percentile 94. What is the median of the upper half? And it divides them, and there is a middle number in here, and it calls it 104. Okay, SPSS analyzes this data, determines the mean, the median, and the standard deviation for the sample, and then it applies it as if That's a population distribution. It calculates the 25th percentile based on the normal distribution that it imagines for the whole population to have. So it comes up with a different number. That may not mean that much to you now, but later on it'll make a lot more sense when we're working with large samples and we're actually looking at the population and stuff like that. When we've learned something about the normal distribution. Okay, so we're getting on 7:43. Any questions? Okay, it's got to be some questions, right? Got dark outside when we're doing this. Depressing, right? We start out in the sunlight, wind up in the darkness. It's going to get worse, right? Wintertime, it's going to get darker. We're going to start in the dark pretty soon. So there must be some questions, right? You guys comfortable with this? Is there anything here that bothers you at all? Okay, SPSS, good luck getting SPSS up and running. Like I said, if you don't have SPSS running by next session, do the homework anyway. Okay.
So,
If you can, you can always get into school. Any one of the computers at all of the campuses have SPSS on the any lab computer that they have there, in the library and so on and so forth. They all have SPSS on them. If you can get virtual SPSS running, great. If you can't, do the rest of the homework anyway. Do the Excel part, for instance, and upload it, and then we'll worry about making sure that you're up and running. We'll get at ICIT. We'll lean on ICIT a little bit more and see if, or IT, whatever they call it, this week. See if we can't get them to get it working. Okay, so shall we call it a night with that? Okay.